Hi, our lesson is on patterns and regularities in the world. Patterns are regular, repeated, or recurring forms or designs. We see patterns every day. We can see it from the layout of our floor tiles. We can see it from the designs of skyscrapers, and as well as the way we tie our shoelaces. In here, we have different designs of snowflakes. And as you can see, we have some beautiful patterns of snowflakes. In animals, we can also see some regular designs in their skin. We can see some stripes, and we can also see some dots. Here are some types of patterns. Symmetry. Symmetry indicates that you can draw an imaginary line across an object, and the resulting parts are mirror images of each other. A perfect example of it is a butterfly. The butterfly is symmetric about the axis indicated by the line. Note that the left and the right portion are exactly the same. This type of symmetry is called bilateral symmetry, or line of symmetry, or mirror symmetry. A shape has rotational symmetry when it still looks the same after some rotation. The smallest angle that a figure can be rotated while still preserving the original formation is called angle of rotation. How many times it matches as we go once around is called order of rotation. The starfish in the figure has an angle of rotation of 72 degrees. As you can see, this is the original position of the starfish. If we are going to rotate about 72 degrees, so as you can see, one was here, now one is already here. Okay, so when we rotate about 72 degrees, this looks exactly the same as the original position of the starfish. But one is already here, as well as the other numbers were already rotated. And then if we're going to rotate, one is already here, another rotation, one is already here, and another rotation, one is already here. So all of the rotations that we did, it will look exactly the same as the original position of the starfish. And if we are still going to rotate it about 72 degrees, it will go back to the original position of the starfish, where one will be here. And so, the starfish has five-fold symmetry. So the order of rotation for this particular starfish is 5. Now another pattern is fractal. Fractal was first used by mathematician Benoit Mandelbrot in 1975 in his book The Fractal Geometry of Nature. Now fractals comes from the Latin fractus, meaning broken, and Mandelbrot defined a fractal as a rough or fragmented geometric shape that can be split into parts, each of which is a reduced size copy of the whole. So, for example, in this picture, if this part of the plant is this way, we expect that the entire plant will look like this as well. Okay? Another example is this tree. So if we will take a look at one branch of the tree, then we expect that the entire tree will look exactly the same. Spiral. Spiral patterns are attributed to complicated mathematical algorithms, sequences, and equations, and are common in plants and some animals like the fern and desert bighorn sheep. So some of the spiral patterns that we can see in nature are this one, the shell of a snail. Then we also have sunflower, as well as um, in outer space like this galaxy. Then we also have spots and stripes that we can see in some of the animals. Like in this example, we have some spots um, in the fish, then some stripes to some of the four-legged animals, as well as spots on some of the four-legged animals. Then we also have desolation or tiling. It is when we cover a surface with a pattern of flat shapes so that there are no overlaps or gaps. Like for example, this one. So we cover the surface with rectangles and then we join them together to create a pattern. Also, we have this. We join two different shapes. We have the square and we also have the octagon. Then we also have these arrays of hexagonal cells which form a honeycomb.